Hey there, in this video we're going to multiply complex numbers that include more than one term. So we're going to need to distribute just like we did when we're multiplying polynomials. So let's start with this first example. We need to distribute and multiply 6 times negative 2, that gets us negative 12, and multiply 6 times 8i, which is 48i. If possible, we might need to simplify some powers of I at the end of our problem. We've seen previously that I has this special property where every fourth power of I shows a repeating pattern. So I by itself cannot be simplified, but any higher powers of I, like I squared or I to the power of 3, should be simplified. In this first example, there's nothing left to simplify, and that would be the complex number that is our final answer. But in this next example, when we multiply, we're going to multiply these coefficients and distribute and combine together powers of I. So negative 7 times negative 8 is positive 56, and we also have an I that we're distributing to that term, so this is 56i. We're also going to multiply negative 7 times positive 3 to get negative 21, and I times I gives us I squared. And any higher powers of I in our final answer should be simplified. So I squared is equal to negative 1, which means that we can rewrite this expression as 56i minus 21 times negative 1. And 21 times negative 1, or rather negative 21 times negative 1 becomes positive 21. So our final answer here is 56i plus 21. But it's more common when we're dealing with complex numbers to write our answer with the real portion first and the imaginary portion second. So let's switch this order around and let's rewrite this as 21 plus 56i. In each of these problems, our answer should look like a complex number in this form, with a real portion plus an imaginary portion, which is some number times I. We do not want to leave any higher powers of I in our final answer other than I to the power of 1, because if there are any other higher powers of I, we can simplify them into one of these expressions here. Now let's do some larger examples where we're going to distribute binomials times binomials, more than one term at a time. We need to multiply the coefficients together and combine together any powers of I. So let's multiply 7 times negative 6 gives us negative 42. 7i times negative 6 gives us negative 42i, and we also have 7 times I gives us plus 7i, and 7i times I is 7i squared because we're combining together the exponents on that I. If we have like terms in our answer, we want to combine those like terms just like we would if we were dealing with a polynomial. So negative 42i plus 7i gives us negative 35i. And we also want to simplify this power of I if it's anything that is higher than just I to the power of 1. I squared is equal to negative 1, so that means that 7i squared is 7 times negative 1, so that's really negative 7. And after we've simplified that power of I, now we've got a couple more like terms that we can combine together. Negative 42 and negative 7 are just real numbers that we can add together. So that will give us negative 49, and then we also have our imaginary component minus 35i. In our next example, we'll follow the same method. So we're going to first multiply each of these terms by each other. Negative 7 times 4 gives us negative 28. 5i times 4 gives us plus 20i. Negative 7 times 7i gives us minus 49i. And 5i times 7i gives us plus 35i squared. Now we have some like terms of I that we can combine together. Positive 20 and negative 49i gives us negative 29i. And I squared should always be simplified to negative 1. So 35i squared is the same as 35 times negative 1, which is negative 35. And now we can combine together the real parts of this answer, negative 28 and negative 35 gives us negative 63. So our final answer is negative 63 minus 29i. And I think to do this next example here, we're going to continue on a new screen so that we've got more room to work. So we've got these two terms in the parentheses that are all being squared. Be careful here and remember that two terms added together and squared is not the same as just squaring each term separately. What this really means is we need to take the two terms that we have and multiply this entire thing times itself. So the expression that we're dealing with here really means we need to multiply 8 minus 8i times 8 minus 8i. So let's multiply together. 8 times 8 is 64. Negative 8i times 8 is negative 64i. 8 times negative 8i is also negative 64i. And negative 8i times negative 8i is positive 64i squared. To deal with these powers of I that are in our answer, we want to combine together any like terms that are just I to the power of 1, and negative 64 combined with another negative 64 gives us negative 128i. We should also simplify any higher powers of I following the pattern that we see up here. So I squared simplifies to negative 1, so this plus 64i squared is 64 times negative 1, which is negative 64. And now we want to combine together the real parts of this answer. Positive 64 and negative 64 equals 0 when we combine them together. So our final answer is 0 minus 128i, or more simply, we can just write this as negative 128i. So in each of these examples, the sequence of steps that we followed was first we multiplied together each set of two terms. Then we combined together the like terms of I and simplified I squared to equal -1, which turns that into a real number. And then we combine together the real numbers to get our final answer. Let's finish with one more longer example. And this isn't any harder than multiplying two complex numbers. It's just that if we're multiplying three or more things, we want to multiply these two at a time. So first, let's multiply together these first two expressions in the parentheses, and then after that, we'll multiply times this third expression. -4 times -5 is +20. -4 times -I is +4i. -3i times -5 is +15i. And -3i times -I is +3i squared. Now before we continue and multiply this times this expression in blue, let's clean up what we've got in red. There's a couple of things we can do. We can combine together these like terms of I. 4 plus 15 gives us 19i. And since I squared is equal to -1, let's turn this I squared into -1, which means that plus 3i squared is really -3. And now we can combine together 20 and, sorry about that. All right, let's combine together 20 and -3 to get 17. So we have 17 plus 19i from multiplying together these first two expressions. Now it remains to multiply this all times -1 minus I. So we've got to do 17 times -1 is -17. 17 times -I is -17i. 19i times -1 is -19i. And 19i times -I gives us -19i squared. We want to combine together the like terms of I. -17 minus 19 is going to give us -36i. Now we can also rewrite I squared as -1. So -19i squared is -19 times -1, which is +19. Now we can combine together the real parts of this answer. -17 plus 19 gives us +2. So we have +2 minus 36i.